Hello, viewers. So here we'll solve some exercises, 7.3. Now, to solve this question, we look at this one. This is 310. 310 is in which quadrant? It's in quadrant 4. And we know the sign is what? Is negative in quadrant 4. So this will be the same as 1 plus sine 360 minus 310 over 1 minus, this will be cosine of 400 minus 360. Yes, here now we are using what? Coterminal. And here we are using reference. So this will be 1 plus sine of 50 over 1 minus cosine of 40. And this is the same thing as 1 plus cosine of 40 over 1 minus cosine of 40. Here we use cofunction identity. So now you see everything in terms of cosine. So we have to look at our options. This looks like what? This definitely looks like tan, the half angle of tan, right? But we know that tan is supposed to be what? It's supposed to be, we can see this clearly. If you remember how we solved this one the other time, if you remember tan alpha over 2, remember tan alpha over 2, it's simply plus minus, right? Sine, it is, or you can say it is sine alpha over 2 over what? Cosine alpha over 2. You remember this? But what is this? What is sine alpha over 2? We know sine alpha over 2 is 1. For sine, it's minus, right? So for sine, it's minus. Okay, for sine, it's root of 1 minus cosine alpha over 2, right? Then divide by, for cosine is 1 plus cosine alpha over 2. And if you look at this, you see that 2 will cancel 2. So this is tan alpha over 2 in a short way. It's just this one. 1 minus cosine alpha over 1 plus cosine alpha. This is before rationalizing and all of that. But if you look at this, you will see that here, something is happening here. Here we have plus, okay? But here, what we have here, it's minus. And the denominators are now the same, they are also reversed, right? So it means that we need to reverse something. So it means that this one is not going to be the same as as tan alpha, right? It's not going to be the same as tan alpha. We can see this because if this is tan alpha, then you can write cotan alpha over 2. So cotan alpha over 2 is going to be the reciprocal of this, which will just be 1 plus cosine alpha over 1 minus cosine alpha, right? So the whole of this, I can write this as cotan of alpha over 2. But what is that alpha now? It's 40 over 2. And this is nothing but what? Cotan of 20. And what is cotan of 20? Is the same thing as tan of what? Tan of 70. So our answer is going to be C. All right. So now let's go to the next question. This one is we are given cosec. We are given the value of cos. We are given cosec. So from here we can get what is sine. So sine is what? Minus 5 over what? Over 13, right? Okay, so what can we say here? We already have two formulas for tan. We know that we have two formulas for half angle of tan, which is either we use sine theta over what? 1 plus cosine theta, or we use the other one, which is 1 minus cosine theta over what? Sine theta. So anyone we use is fine. So that is what we're going to do here. So let's use which one? Let's use the second one, or we use the first one, which is sine theta over 1 plus cosine theta. What is sine theta? Minus 5 over 13 over 1 plus cosine is negative. So this is negative 12 over 13. And this is just minus 5 over 13 divided by, this is going to be 13 minus 1. So 13 minus 12. This is just going to be 1 over 13. So 13 will go with 13. And our answer is just minus 5. Right. So question number 3. For question number 3 is, we are given that cosec is this and x is in the third quadrant. So let's go to the third quadrant. And let's draw our x. Cosec is what? Is the reverse. So this simply means that sine x is what? Is minus 3 over 5. Correct? So the opposites, sorry, quadrant 3, not quadrant 2. Quadrant 3 is this way. So this is x. Opposites is going to be 3. Hypotenuse is still 5. Then the adjacent definitely is going to be minus 4 here. Okay. Now we want to find this values. So this is sine 2x. Let's start with sine 2x first. So sine 2x, we can use any of this formula. Is 2 sine x cosine x, which is 2 times, what is sine x? Sine x is minus 3 over 5. And what is cosine x? Cosine is what? Adjacent. So it's going to be minus 4 over 5. And this is nothing but this minus and this minus will cancel. So you will have 24 over 25. This is sine 2x. Because you have 12 times, no, did I say 24? No, it's not 24. Because here you have 2 times what? Times 4, which is 8. 8 times 3, yep. We're right. 24 over 25. Okay, now let's get cotan x over 2. This is just going to be the reciprocal of tan. So what is tan? We already saw the formulas for tan. So if this is tan, I can just take the reciprocal of this and use it for what? For cotan x over 2. So that means we can take it as 1 plus cos theta over sine theta. So 1 plus cos theta over sine theta. We can use this. And what will this be? So here, we will have 1 plus What is cosine theta? Cosine theta again, it's what? It's minus 4 over 5. Divide by sine theta, which is minus 3 over 5. Yes. And this is nothing but what's this is going to be 5 minus 4 over 5 divided by minus 3 by 5. And this is 1 over 5 divided by minus, or which you can change to times. This is going to be times 5 over minus 3. So this is just minus 1 over 3. Yep. So this is cotan x over 2. So if you put this together, what do we have? Because we want to add. Okay. So here now we have that's what sine 2x plus cotan x by 2 is just 24 over 5 plus minus 1 over 3. And this is 24 over 5 minus 1 over 3, right? And here we can multiply this by 25 and this by what? By 25. So this is going to be 24 and this we have to multiply by 3 as well. We have to multiply this by 3. We multiply this by 25. 25. Yeah. So this is going to be 272 minus 25 over 75. And this is nothing but 47 over 75. So that is the answer. Okay. Now let's see the next question. So here we want to find the exact value of this much. So what can we do here? Sine 13 pi over 12, cosine pi over 12. Okay. So this is going to be what? Cosine, right? This expression, we can write it as, we have to look at what is 13 pi over 12. This is going to be sine 13 pi over 12 is in which quadrant? You can see that this is definitely in quadrant number 3. Yes. So sine is negative, so this will be minus, right? And then we will use 13 pi by 12 minus pi. This is a reference. Multiply by cosine pi over 12, right? So everything will be minus sine 13 pi by 12 minus pi will give us pi over 12 cosine pi over 12. Okay, so now we have this one. But if you look at this, this looks like what we know. This looks like sine. If you remember, sine 2x is what? Is 2 sine x cosine x. So it means if I have this one, we just have a minus attached to it. So it means that since I have pi over 12, so I have sine pi over 12 cosine pi over 12, right? This ordinarily, if I have it, so let me just have it out. Sine of what? 2 times pi over 12 is supposed to be this much, right? So I'm just trying to create what we have. So it means we need to multiply by minus. But here there's supposed to be a 2, right? It's supposed to be a 2 here. So if I divide both sides by 2, so we'll have 1/2 sine 2 times what? Pi over 12 is going to be sine pi over 12 cosine what? Pi over 12, right? Now we need a minus, so we can introduce a minus. So this means that minus half sine to this is just minus sine pi over 12 cosine pi over 12, right? Okay, so this should be a sign here. Write it again. Pi over 12 cosine pi over 12. So it means that this is nothing but what? Half. So I can use this formula now. This is nothing but minus half sine 2 times what? Pi over 12, which is minus half sine what? Pi over 6, right? But what is pi over 6? Pi over 6 is sine 30. So you have minus half times half, which is just minus 1 over 4. All right, and let's see, do we have one more? Okay, this one is saying the expression, this simplifies to. All right, so here, what can we do? This is an simplification. We can look for what is common. What is common? We see that, is it cosine that is common? Only cosine. No, sine is common, so I think we can take 4 is common. Sine x is also common. Cosine x is also common. So we'll be left with what? We left it cosine squared x minus sine squared x, right? So what is this? Okay, so what is this one? This is 4 sine x. See this? Cosine x. This is nothing but what? Cosine 2x, right? This is a double angle for cosine 2x. But this one also, we can write as what? We can write this as 2 multiply by what? 2 sine x, cosine x, then times cosine 2x. So if you look at these two now, from here to here, this one. If you look at this, this is nothing but what? This is nothing but sine, yes? So this is nothing but sine 2x. So this is 2 here. But this one here is nothing but sine 2x, right? Because why do I say so? Yeah, we know that sine 2x is what? Is 2 sine x cosine x. So that is what we use. And here we still have cosine 2x. But if you look at the whole of this, just let's develop it from here. We agree with this one, right? So now, if we agree with this, now let's write this side. Let's, instead of x here, let's make here to be 2x. So you'll have sine 2x cosine 2x. So what did I change? I changed x now to 2x. So once you do that, then on the left-hand side also, you have to change x to 2x. I'm just using this formula. So this will become sine 2 times what? 2x. So I'm just replacing x with 2x. So this will give us sine 4x is equals to what? 2 sine 2x cosine what? 2x. So we note what is happening here. Here is 2x, here is 2x, here is now what? 4x. So unlike in this case, where here it was x, and what? 2x. So see the changes? So here we have to multiply by 2. So it means that this term here, the whole of this is just going to be sine of what? 4x. All right. Okay, so that is the end of this video. Thank you for watching. Like and share, and also subscribe to this channel. Thank you, and I'll see you in the next video.